that I can put this on the site later in case we have some questions. Not a lesson today, but we are going to do some more things with equations, and I want to make sure that we're all on the same page with this. Okay. First things first. Directions. Always important to read them. Find the value of y for the given value of x by first solving for y, then substituting the value of x in. Now, I know what some of you are thinking already. Well, but I could just plug in x for 5 right now, and this would be easy and go fast. I understand that. But part of what I'm trying to do here is get some of you used to getting equations into slope-intercept form because lines are coming, and we have to be able to make those adjustments. So it's just kind of previewing that a little bit. So stick with me. My first step is to work on solving for y. So just like we were talking about with the equation stuff, right now I'm adding 3x to 2y. I got to do the opposite. So I'm going to get that out of there. But here's the one thing that I would suggest you do to try and make it a little bit easier. What's my last step going to be to get y by itself? Divide by 2. I would keep this as a whole fraction. You don't have to. You could absolutely, if you wanted to, make this negative 3 over 2x plus 1/2. You absolutely could. It'd be more of slope-intercept form. However, here's the deal with that. If you put it into the other form and then you go to plug in the 5, you're going to have fractions that you're dealing with when you're trying to calculate it. I personally wouldn't want to deal with a fraction. Those are no fun. So here's what I would do. Once I had that set, then what I'm going to do is, now I'm just going to plug in the 5 where the x is at. So my last step is going to be to plug in 5 where x goes and calculate this. But similarly to what we've been doing in those last couple of story problems that we were looking at from the assignment, be careful, because if I just type this all in, I'm going to get a goofy answer. So again, think of them separately and use some mental math here. You know, challenge yourself and have some confidence with that. So here I'd have negative 15 plus 1, which would be negative 14, divided by 2, which is negative 7, and I'm done. Okay. And again, we're going to take a look at another one of these too, just to kind of get us into the role of getting used to solving these and trying to work on getting these in the right form for us. Okay. Because number 2 will get us back into a little bit of what we were talking about on Friday. This whole dilemma of, well, wait a minute, I'm trying to solve for y, but there's 2 y's here. And we said y can't be part of the answer if I'm trying to solve for it. So does anybody remember how we got around that dilemma on Friday? It'll be something like that. It's almost like, yeah, the opposite. We're going to take the y out of there because we have a y in common. By doing that, now I take whatever is left over, or whatever I need to multiply y by to get each of those back. So y times x is xy. Y times negative 2 is negative 2y. And all of a sudden, I've gone from having 2 y's down to 1. And now I can solve for y. But again, just remind yourself, what am I doing to y? And then do the opposite. Right now, I'm multiplying y by this set of parentheses, this quantity, x minus 2. So, the opposite of multiply is to divide So I get my y by itself. And my first job's done. I've solved the equation for y. Once I do that, the only step I have left is to now take this equation and plug the x value back in. So that x becomes its value, okay? It's no longer a variable, it'll be a value of 3 minus 2. And 3 minus 2 is 1. 12 divided by 1 is 12. And I've got my last part done. When x equals 3, y equals 12. But again, the process behind that is getting you used to solving for a variable, then actually getting to work with the value that's involved. For the next group, it's just like what we were doing before on Friday. Whatever it says, the 4 and whatever variable is after it, that's the variable you are attempting to get on its own. And I'd really suggest having out that example sheet we were working on Friday, because some of these are similar, or at least give you an idea of what you may want to do on some of these. So like for instance, let's say on number 6, we were trying to get h by itself. You're like, ooh, that's going to be kind of tricky. There's lots of other stuff here. That's true. But again, just keep trying to get little pieces away. Well, first, looks like h is in a fraction. We don't want to be fractional here. How do I get rid of this divide by 2? Okay, so we're going to multiply both sides by 2. Now, on this right side where all this stuff is, the 2 is just going to cancel that 2 in the denominator. That's its whole job. So 2a got rid of the fraction on the right. We kind of go that way. But then I got to keep in mind for myself, because you may think about distributing next, but think about what the goal is. The goal is to get h alone. Right now I'm multiplying h, again, by a set of parentheses. This quantity, b1 plus b2. So what would be the opposite of multiplying by the quantity? Divide. So don't make yourself extra work. You can divide by that whole set of parentheses. You don't have to do it piece by piece, because then that'll go away. And I'm done. Now, could I get there doing it the other way? Sure. But it's going to take me more work, and it also kind of makes things a little more complicated. I don't want to make stuff complicated. Yeah, I want to make it as simple as I can. Number 7, I took something away, and besides that, I probably should have taken these away at the same time if I was going to take the other part away. Because, yeah, those parentheses aren't really going to do anything when there's nothing in front there. So we can go ahead and get rid of those, and then that should make that a lot easier to work with. It's just capital R plus lowercase r. So that should work out pretty slickly. On number 9, I did notice the typo. My L's disappeared. My length and my length disappeared. So on 9, you're solving for L. You're solving for the length. And then you've got all the rest of the information that you need there. Now I'll admit, when I got to the back of this page, I did kind of start to ratchet things up a little bit on a couple. So let me help on a couple of things here, because I don't want to leave y'all high and dry. So there's 2 of them that I want to take a peek at. I want to take a peek at number 4, and I want to take a peek at number 5. And then I'm going to let you kind of work on your own here for a bit, and we'll kind of see how things are going. Okay, number 4. It says solve for y. Okay, well, one happy thing. I notice there's only one y, so it's not like there's multiple ones that I have to concern myself with. So in this case, anybody have an idea on what I might want to do first to start working on isolating my y term? Okay, add the 10x to the other side. You get 10x squared. And some of you may say, well, now do I have to, is there a certain order like we were talking about before? There isn't. Normally, I'll put my term with the greatest degree first, but if you switch them around, that's not the worst thing that's ever happened. But again, so now we've got our y term alone, but I want to get y by itself. Okay? And since it's all being multiplied together, right, I want to divide by all that other stuff. And there's just one small forewarning that I want to talk to you about on this one. Because you start to look at this, you're like, well, I'll just write it down. I'm good. One thing. Check out the numbers here. Is there a number that divides into all three of those? Yeah, 5 does. So if you can do that, you need to. So since these are all divisible by 5, not 2 out of 3, but all of them, I'm going to divide each of these by 5. Before I go to my last answer. Now, it wouldn't be completely wrong even if you left it that way. It'd be a partial. It'd be you didn't simplify it, like you don't simplify a fraction sometimes. But here's the thing that I know somebody's thinking and they're not saying, so I'll say it for you. Well, can I just cancel these out then? No. And here comes my goofy way of remembering things again. Whenever you see a plus or a minus with something, that automatically bonds those things together. So unless I can take something from both of them, I can't take anything at all. And I always say, if you can see a bond, it's really strong. Notice a multiplication bond here, I can't even see the bond. It's kind of weak. So I compare all these bonds and things to like dating relationships because it's easier to remember that way. They're like, oh, good grief, he's nuts. Yeah, I said I am. If you can't even see anything, that it's sort of like when you say you've got a boy or a girlfriend, but you like walk down the hall and you're like this far apart from each other. It's like, and you're kind of going, we're just waiting for something bad to happen here. And so with those, if it was just multiplying, heck yeah, I could cancel them out. Something good comes along and break it apart. Okay. But the bond here, okay, I can see it. It's strong. Now we're like going down the hall, holding hands, and there might be like class rings getting switched around and all that other fun stuff. If I can see the bond, the only way I can break this up is if I see something identical with everything. X squared tries to get in here, but that 3 says, back off. So that's sort of how I like to look at things like that. But again, with the numbers, if it's something that goes into all of them, I know it's a lot to keep track of, but that's the great thing about math. It makes you really learn how to pay attention to a lot of details. And that helps in a lot of careers, not just, you know, doing a math problem. All right, last one I'm yammering about. Solve for x. Okay. I need to get x squared alone first, I guess. What could I do? Okay, I could add 8 to start getting my x squared alone. All right. We're getting there. What else? We'll deal with that momentarily. Okay, subtract the y. Because we need to get all this stuff away from our x squared. And again, if you put 8 minus y, that's perfectly acceptable. So finally, x squared, squared. What's the opposite of squaring something? Square root. Squared and square root are inverses. They take care of each other. So you mean I can even get answers that have square roots or squares? Yes. Yes, you can. Because we're going to be flexible on the things that we allow ourselves the opportunity to be able to solve for. So if for some of you the idea of all this stuff with equations is kind of driving you crazy, we're doing it today. We're going to spend some more time tomorrow doing it too. And I'll be getting the quiz preview out. We're going to talk a little bit about story problems and bringing all that in. But for right now, my suggestion would be keep firing away at this, and if there's a couple of the other homeworks that you haven't gotten around to yet, kind of start working with those too, because it'll also give you good practice for when we get to that quiz midweek.